Okay, this is the podcast to know how waves behave. So you're going to be using your little foldable that you picked up today. Now how this foldable works, there are lines that shows where you fold it in. So where you, if you lay it flat and you fold the two flaps over so that you can see reflection, refraction, diffraction, and interference. And then we can cut just under those top two words so that when you open up flaps, you can see the information. So hopefully that is easy to understand. So the first thing we're going to talk about is reflection. Reflection, everybody knows what it is. When you look in a mirror, you see your reflection. Well, a reflection occurs when a wave strikes an object and bounces off of it. All types of waves, including sound, water, and light waves, can be reflected. Some examples of this would be a wave hitting the side of a pool and bouncing back. So obviously that would be a water wave. A sound wave hitting a rock wall and bouncing back as an echo. So you might not have thought of an echo as being a reflection, but it's just a reflection of sound. So here are some different water reflections that are pretty neat, I thought. All right, so the illustration that you're going to be doing, you're going to create a line that represents the mirror. Okay, looking at the information that I have here, it says the angle of incidence of a wave is always equal to the angle of reflection. So what that means is, if we have a light, so the light, let's say it's a flashlight, and we shine it towards a mirror. Okay, so again, that's angle of incidence. I'm going to label that I. It is going to equal the angle of reflection of that wave bouncing off. So I'm going to label that R. So we're going to pretend that there is this imaginary line going through that. So as the flashlight hits the mirror, let's say it hits it at a 20-degree angle. That means it's going to bounce off at a 20-degree angle. So the angle of incidence always equals the angle of reflection. All waves react this way, not just light. Now refraction. The bending of a light wave as it enters a new medium at an angle other than 90 degrees. Now the reason why this is going to happen is because your object is traveling at different speeds when it enters new mediums. So for example, your legs look broken when they are half in and half out of a pool. Here's another picture. So you can see that this pencil is half in the water and half out. So this part of the pencil is in a gas, and this part of the pencil is in a liquid. So because of this, it appears to be broken right here where the two mediums meet. This becomes apparent when you are trying to fish. A lot of people like to try to hand fish. Now, when you do this, you are going to see a fish at a particular angle. So looking at this illustration here, you're going to see that the fish is there. If you reach your hand there, you're definitely going to miss the fish. But because light is bending as it goes into the water, you need to be reaching just a little bit closer to you. I know there's some people who bow fish, like my husband, and he has to take this in account when he does that. Otherwise, he's going to miss all the fish. So let's do an illustration. We're just going to do the pencil in the water. So for this is the actual pencil in the water. So we have the cup. Let's go ahead and draw in the water. Draw the pencil. And let's show that the pencil is broken. Now I want it to be able to label that this is a gas. Hopefully your illustration looks better than mine. This is a liquid. And the reason why it appears broken is because we are changing mediums from gas to liquid. So again, hopefully your picture looks better than mine. So I just did mine real quick. All right, so now diffraction. The movement of waves around a barrier. Some examples. Sound waves diffract when they go through an open door and spread to the space outside. So now think, sometimes when I'm teaching and I have my door open, we can hear people out in the hallway. They're not necessarily right in my doorway, but this just shows that sound waves can bend. Sometimes I can hear Mr. Hot. So not only does it go out his door and around, but it also goes out his door, around, and in my room. So it has the ability to bend around obstacles. Another example, water waves going around your legs at the beach. Note, diffraction and refraction both cause waves to bend. The difference is that refraction occurs when waves pass through an object, while diffraction occurs when waves pass around an object. So this would be an example. We have barriers here with the logs, and the water has the ability to go through them. And not only does it go through, but it's also expanding after it goes through. Here's another example, very similar. All right, so our illustration. I'm going to do two illustrations. The first one, I want you to have just one object, and I want you to show that the water starts going to that object, and then it goes around the object, and as it gets around the object, it expands. Another example, we have two objects. The water is going towards it, then it has to go through it, and then it expands. So it is bending around the object. So not only does it work with water waves, but we said I gave you an example of sound waves as well. So again, at any point, you can pause this podcast, you can rewind, you have the ability to do that. All right, interference. Interference is going to occur when two waves interact or come together. Constructive interference, we have two waves meet crest to crest, resulting in a larger wave. Destructive interference, two waves meet crest to trough, and the resulting wave is smaller. Some examples of constructive interference. When you have water waves that meet, they end up getting larger. Destructive is when sound waves meet, they get quieter. All right, so this is when water waves have met. Constructive interference, you have one wave that came in, one wave was going back out. They met and created this big splash. Destructive interference, we have two fishermen. They're both creating waves from their lines that they are putting in, and as those waves meet, they kind of cancel each other out. All right, so we have, again, two illustrations. We're going to have one that represents constructive interference, and we have one that represents destructive interference. Okay, so constructive interference. I'm going to have two waves. I'm just going to draw transverse waves. You notice I drew my transverse waves so that I have crest to crest, trough to trough. So I'm adding these two waves together. So let's say that this wave has an amplitude of 2 amps, and this wave has an amplitude of 3 amps. Because we have crest meeting crest and trough meeting trough, they're together. When they go on top of each other, at the same time, I'm creating a larger wave that would have an amplitude of 5. Okay, so we have two sound waves. So let's say I have one person singing and then a second person comes and sings the exact same song. Well, because you have two people doing it and the exact same words, it's going to appear louder. Okay, destructive interference. Okay, so I have a wave. I have a second wave that comes in and interferes with that. However, this wave is going trough to crest. So if you notice, crest, trough is how I drew this. So with constructive interference, I added their amplitudes. With destructive interference, let's say I have 5 amps and 3 amps, I would subtract. However, looking at my two examples, the larger has crest first, then trough. So the resulting one would have a crest first, just like this one, because it's the larger one. However, the amplitude would be 2. So this would be an example of if you have somebody singing at 5 amps, somebody comes in and sings a different song at 3, they're going to cancel each other out, and it's going to be really hard to understand them. However, the one that is singing louder, you're going to be able to hear better. However, you're only going to hear about 2 amps of it. All right, so that concludes the podcast on behavior of waves. When you are finished with this, I want you to be able to complete all the task cards.